We are going to be talking about expanding polynomials today, and we'll first review what a polynomial is and the characteristics of a polynomial, and then look at some special cases for multiplying that will make life a little bit easier for us. So remember, a polynomial is a collection of terms where your exponents are whole and positive numbers, and that we have no denominator variables in the denominator. So this is a polynomial. 2x to the third minus 5x to the seventh plus 2 plus 3x. Now to put it in standard form, we always want to go in order of power from largest power to the smallest power. So negative 5x to the seventh would be first, then positive 2x to the third, then positive 3x, then positive 2. So our exponents go from largest to smallest. Now the degree of the polynomial, to figure that out when you have a polynomial in standard form, you always look at the highest exponent. Highest exponent. That's different than if the polynomial was in factored form. We do something different for that. So in standard form, we always look at the highest exponent. Now the leading coefficient is the number in front of the highest exponented variable. So this leading coefficient is -5. So I just want to make sure that when we are subtracting polynomials, that we remember to distribute the negative sign if need be. So here we have 10x minus, and then in brackets, which are just another set of parentheses. Instead of writing, parenthesis and then parenthesis like that, to make it a little bit more confusing, we can use brackets instead. So just think of brackets as additional parentheses. We need to distribute the negative sign first. We have 10x minus, and then in brackets, or you can change it into parentheses if you want. So now we have 10x minus 4x minus 3x is 1x, and then we have minus 8. So now we can take this subtraction sign, and you could distribute it if you want, or just do 10x minus x, which is 9x, and then we have nothing minus -8. Well, minus -8 is going to be plus 8. So we have 9x plus 8. Example number 3 here. Again, you could distribute the negative sign, or just know that you can combine like terms and make sure that you are minusing each of these things. Because what usually would happen is students will only take this subtraction sign to the 14x and then forget the -7. So if you want to distribute it, that's fine. So we have 7x squared minus, well, we have no x squared, so it's going to be -7x squared. Then we have 12x minus 14x. That's going to give us -2x. And then we have 3 minus -7. Well, 3 minus -7 is going to be 3 plus 7, and that gives us 10. So that would be our simplified polynomial. Now, when we multiply polynomials, we have some special cases. One of them is the sum and difference of the same terms. When we were doing multiplying by the conjugate in the radical section, our conjugate followed these same rules. You could multiply this out by foiling first, outside, inside, last, but when you do that, you're going to see that the middle terms are going to cancel out. So we can do a shortcut and say, oh, a and a is a squared minus a and b squared. So that middle term, when we would multiply by foiling, we would do this and get AB, and that would be -AB. Those would cancel out, so we can skip that part. Like I said, that's what we did for the conjugate. Now the square of a binomial, so notice the difference, a plus b quantity squared. We could FOIL that out if we wanted to, a plus b times a plus b. Remember, you cannot just say, oh, this is going to be a squared plus b squared. No, that's not how it's going to work, because when we FOIL this out, we would get a middle term. So like I was saying, you could multiply and FOIL this out every time, but a shortcut would be a squared plus 2 times a times b plus b squared. So that would be your middle term here. And you'd multiply it by 2. A minus b quantity squared, again, would be a minus b times a minus b. That would equal a squared minus 2ab plus b squared. Now, these shortcuts will make it a bit faster, but if you ever forget the shortcut, no, you can just multiply it out. Now, the cubes of a binomial. So we have a plus b quantity cubed and a minus b quantity cubed. Again, we could write it as this and multiply it out, but that is going to get time consuming to do that every single time. The shortcut we can say is a to the third plus 3a squared b plus 3ab squared plus b to the third power. So notice we have these two middle terms where we have the coefficients are both 3, and your exponent goes a squared b and then a to the first power b squared. One of the ways you can think about it is look at your exponent for a. 3, 2, invisible 1, no a, or a to the 0 power, which is 1. Your exponent for b. 3, 2, invisible 1, 0. And then b to the 0 power is 1. Then a minus b cubed. Again, we could write it all out. I'm not going to do that. The shortcut a minus 3a squared b plus 3a b squared minus b to the third. So this one's a little bit more confusing because you would think, oh, it's going to be minus minus, but it's not. It's minus then plus, whereas the one up here is plus plus. You would think, oh, then the one down here in blue should be minus minus. That's not the case, so that is a little bit confusing. All right, now down here we're going to multiply, leave in standard form. The beautiful thing with multiplication is that we can rewrite them or do them in different orders to make life a little bit easier. In this one, I would multiply these first. Negative 2x times negative 3x, that gives us positive 6x squared. And then I can multiply that by 5x minus 4. So we'll distribute, and that's going to give us 30x to the third minus 24x squared. And then example number 5 here, we have a trinomial multiplied by a trinomial. So this can get a bit confusing. You can draw it as a box. And let me show you what that would look like. I would write x squared plus x minus 2. Maybe I would spread them out a little bit more. And then on the side, I would write the x squared minus x plus 2. Now, some people don't like to write it this way because it does take up a lot of space. I do like it because it's sometimes hard for me to remember, okay, I got to multiply that, and then I got to multiply this, and then I got to do the same thing with negative 2, and it looks very messy, and it's hard. It can be very easy to get things all mixed up. So by doing it in this box, I can say, okay, x squared times x squared, that's x to the fourth. X squared times negative x, that's negative x to the third. X squared times 2, that's 2x. Then we have x times x squared, that's positive x to the third. x squared times negative x, that is negative x squared. X times 2 is 2x. I'm sorry, this one should be 2x squared. X squared times 2 is 2x squared. Then our last one, negative 2 times x squared is negative 2x squared. Negative 2 times negative x is positive x. Positive 2x, I'm sorry, positive 2x. Then we have negative 2 times positive 2, that is negative 4. Now, when we make the box this way, look at your diagonals, your like terms. This is x to the fourth. Then we have this diagonal are the x to the third power. This diagonal, all your x squareds. This diagonal, x to the first power. And then we have our constant. So your like terms are organized very easily to see that we're going to have x to the fourth, x to the third minus x to the third. Well, that's going to go away. That's 0x to the third. Negative 2x plus 2x is negative 2x squared plus 2x squared. And then minus x squared, that's going to be minus x squared. 2x plus 2x is 4x, and then we have that last constant, negative 4. And that would be our answer in standard form. So if you did multiply it all out like I was showing with the arrows earlier, you would get the same answer, but to me this is an easier way to organize it and make sure all your terms, all your like terms follow a nice pattern. All right, number 6, x minus 4 squared. And like I said earlier, you could write it out, x minus 4 times x minus 4, and multiply it out, or use the shortcut. And I'm going to show you both ways for this one because this one is not as time consuming. So we have x squared minus 4x minus 4x plus 16, which would be x squared minus 8x plus 16. Now the shortcut for this one, if we look back up here, is a squared minus 2ab plus b squared. So your a is x and your b is 4. So the shortcut would leave us with a squared, so x squared minus 2 times a times b. I'm sorry, b is 4. Plus b squared plus 4 squared. And if we simplify that, we get x squared minus 2 times x times 4 is negative 8x plus 4 squared is 16, which is exactly what we got here. So on this problem, it probably didn't take much more time to write it all out. But when we have bigger numbers and your a value is not 1, it can take more time to write it out, multiply it, and combine like terms. All right, on to the next page, we have 2x minus 5 raised to the third power. We can write it out 3 times and multiply it out again, and you get the same answer. But I'm going to show using the shortcut. Our a term is 2x and b is 5. The negative sign just tells us what rule to use. So if we use that formula, it's going to be a to the third power. A is 2x, so that whole thing, 2x, needs to be in parentheses, minus 3a squared, so 2x squared times b, plus 3a, so 2x times b squared, minus b to the third power. So you're going to see that this is going to take significantly less time than writing it all out, but I also understand that if you forget the rule, you need to have a backup, so writing it all out would still get you the same answer. So 2x to the third power, 2 to the third power is 8, so we have 8x to the third, minus 3 times 2 squared. So we have to do 2 squared first, which is 4. So 3 times 4 times 5 is going to be 60. We have x squared. Then here we have 5 squared, so 25 times 2 times 3 is going to be 150x, and then minus 5 to the third. 5 to the third is 125. So there we got our answer much quicker. All right, number 8 is 2x plus 3y squared. So now we're going to use the shortcut right here. A squared plus 2ab plus b squared. So again, your a is 2x and your b is 3y. So it's a squared, so 2x squared plus 2 times a times b plus b squared. So 2x squared is going to give us 4x squared plus 2 times 2 times 3 is 12. So we have 12xy plus 3y squared is going to simplify to 9y squared. So I think you can agree that this was quicker than writing it out and multiplying it and combining like terms. Right, this one is a sum of a cubic. So this is our a value, this is our b. So it's going to follow the same pattern with our coefficients and exponents, except this one was a minus, so our first term here was negative. All right, so it's going to be a to the third, so 3 to the third, plus 3 times a squared times b plus 3 times a times b squared plus b to the third power. 3 to the third power is going to be 27. Plus, we have 3 squared is 9. 9 times 3 times 4 is 108. 108x. Plus, we have 4x squared, so 16 times 3 times 3 is 144x squared. And then we have 4x to the third power. That's going to give us 64x to the third. Now, the direction said to write in standard form. This is not in standard form because the biggest exponent isn't in front. So we need to rewrite this where the exponents go in order. And that would be our final answer. So number 10, we have a fraction here. Now, you may be tempting to say, oh, I'm going to cancel off these 2's, but because we have an exponent here, we must do that first before this multiplication. So I'm going to use the rules of exponents that says I can do this, x plus 1 squared over 2 squared. Because now that numerator becomes much easier to work with, and I can use our pattern from above. So I'm going to have that 2 hanging out, and then in parentheses, that x plus 1 quantity squared using our rule is going to be x squared plus 2x plus 1. Because our a value is 1, and our a value is x, and our b value is 1. And we have that, whoops, we don't want to do that. We have that all over 2 squared, which is 4. Well, now that our exponents are gone, we can simplify this. 2 and 4 would simplify to give us x squared plus 2x plus 1 over 2. And we can go a little bit further and write that as x squared over 2 plus x plus 1/2. Separate that fraction into individual terms. Number 11, there's no shortcut for this one. This is just standard foiling. 7x times 3x is 21x squared. 7x plus 5y is going to be 35xy. Negative 2y times 3x is going to be negative 6xy. And then lastly, negative 2y times 5y is going to be negative 10y squared. We'll combine our like terms to give us 21x squared plus 29xy minus 10y squared. Now our last example here, I noticed that these two are the same terms, but one is negative, one has a negative sign in it, one has a positive sign in it. So I'm going to rewrite this as 2x minus 1 times 2x plus 1 times 3x plus 2. Because now I'm going to multiply these two first using the rule from the first page where I just have to multiply these two to get 4x squared and these two to get negative 1. And then I can multiply this by 3x plus 2. That just makes it a little bit easier. Okay, so now we're going to FOIL this. 4x squared times 3x is going to be 12x to the third. Then 4x squared times 2 is going to be positive 8x squared. Negative 1 times 3x is negative 3x. And negative 1 times 2 is negative 2. We can't combine anything, so this is going to be our final answer. So you may need to review this video a couple times to really understand and recognize those patterns from the first page. But like I said, you can always multiply it out, but these patterns are going to make things go by much quicker. So thanks for watching. Make sure to like the video and subscribe.